We have another Whirlpool microwave where the customer said it's not heating properly. As usual, the first thing you want to do is you want to verify the customer's complaint. So we're gonna add 30 seconds. And when we did, we noticed the machine is counting down. The light is on, but the turntable is not turning. So that's the symptoms that we have. So again, we're gonna turn it off. We're gonna unplug it for safety. And we're gonna concentrate on the schematic. Can I see the highlighter? All right, so what's not working? The turntable is not working. The fan mode is not working, but the clock is counting down. Okay, so at this point, we're gonna look at the circuit. So based on this, if the primary interlock switch is open, this circuit does not work. So that's probably where I'm gonna start first. We're gonna ignore the filter, we're gonna ignore the magnetron thermostat, we're gonna ignore the cavity thermostat, and we're also going to ignore the relay because, like I said, if this switch is open, none of these work. As you can see, the clock gets its path from here, so that will work. Everything after this section is not working. So we're gonna go to the primary interlock first. So if you look at the schematic, guys, we have 3 interlock switches in the door. We have our primary interlock switch, we have our monitor switch, and we also have a secondary interlock switch. So we're gonna go to the microwave itself. So here we have our 3 switches, right? So on this one, we can find out the primary switch 2 ways. On the schematic, it says it's the upper interlock switch, or you can go with the wires. You got black, black, brown. This is the only switch that has a black, black, and a brown. Again, what I like to do is I like to disconnect. I like to make sure I isolate my problem. I disconnect the switch. It's a quick disconnect so you can't mess it up, right? The door is closed in this position, so you should always get 0 ohms on a closed switch. So we go like this, and we check the switch, and we got infinite resistance. Let me zero my meter to make sure we're on ohms. Check it again. And we have open line, which is a defective switch. Now let's go ahead and check the secondary switch, which is at the bottom, so we can see what a good switch should be. Again, the secondary switch is at the bottom. I'm gonna open, and we're gonna check it. Marquise, can you come over here and help me? And right here we got 0 ohms, which is good, but we have to open the microwave door. Open the door. Open the door. When we open the door, you should have infinite resistance, which we do have. Close the door. It's not making contact. All right, let's do it. Let's see. Go ahead, open the door. Close the door. There we go. So that's a good switch. So in this situation, the reason why it was counting down and it wasn't heating is because you have a defective primary interlock switch. If the primary, so when we do a microwave, all right, if this machine came on and it ran, but it doesn't heat, the check that we want to make is we want to check between 120 volts and the transformer primary winding. This is the transformer primary winding. So if this unit ran and it doesn't heat, we check between here and here for voltage. If you get 120 volts at this terminal on the transformer, which is the primary winding, it indicates that our problem is on the low voltage section. And based on this schematic, we have 3 components that can cause it to not have voltage. Actually, we have the secondary interlock switch, which is connected to the control board, but we also have our relay and our primary interlock switch. But if our primary interlock switch is defective, it will not come on. It will just count down. So if it runs but doesn't heat, we have voltage at the primary winding, then it has to be the heat relay. And how do you check a heat relay? You activate the circuit and you check for voltage. If you get 0 volts when you check for voltage while it's running at the primary winding of the transformer, it indicates that our issue is on the high voltage section. In this situation, you want to unplug the microwave. You want to discharge the capacitor. The capacitor is right over here. You want to make sure you discharge the capacitor before you start ohming out everything on the high voltage section. The high voltage section components are you have the magnetron, or a transformer, or a diode, or a capacitor. And again, most likely you want to make a check at the transformer primary to make sure it's open, or you got resistance. You should get between 0 to about 90 ohms.